think we can start from this side. Okay, so if you tried already upload it on the, I already downloaded, so you can open it. Otherwise, you can use your own USB disk to update your presentation. So how about you first? So you need to present, yes.
I need to do something about them.
Do you have your
my TI is
which one?
108.3.22.904.
904.
Yeah, this one.
This one.
Yeah.
Okay. So let's start it. Okay. Let me check how to. Okay. So. Okay. Go ahead.
So
you can.
I'm going to talk about an innovation and about the Buffalo Creek Dam. It's in West Virginia, in the eastern part of the USA. So it comes in 1972. It's a very different time from now, and we'll see why.
Can you use the mouse?
Oh yeah. Okay. So in the Buffalo Creek there was a coal mine, and so they used to throw the water, the muddy water, outside, and for that they used 3 dams, 3 earth impoundments. So you can see there. The first one upstream is the third, then downstream the second, and then the first. And so the river came down on a valley where there were the workers of the coal mine. And so on the 20th of February 1972, after lots of waterfall on the region, the dam 3 collapsed and lots of people died. So the one thing that's very important to know about this disaster is that the company built the 3 dams, and they managed them without any involvement of the local government. So basically, they had free access, and they could do whatever they wanted. And so we're going to talk about why it was an issue. So 125 people died, and 4,000 lost their home. So mainly coal workers, and basically very low insurance, because it's the US, and the workers in the US don't get that much rights, and so it was a tragedy. So on a physics level, what happened? So the dam were built without proper engineering, because the company did not have to hire engineers to do that. They could do whatever they wanted. No oversight for the government, so no problem with that. And they could even ignore the results for the inspection, and all the inspection covering the period of the 19th of September 1966 to March 25, 1971, were resulted in defaults in the dam, but the most important person on the site, which was the company's vice president, always used to ignore them. This is because he had made a sketch for the dam 3, which was the only piece of engineering done, and he didn't want any personal responsibility on this. And because if they were to repair the dam, that would cost money and make it so that they don't make as much money as they could. So because they want as much money as they can, they won't invest in the dams. But so the department still had a look on the dams, and the department said that there was no emergency pipe, because if there's too much water, then you need to a way to get the water out to avoid overtopping of the dam. And so they asked the company to add a pipe to an emergency pipe, and the company did it, but only with a 60-centimeter pipe. Imagine on a big old dam, a pipe like that, that's almost nothing. It's a joke. So on the 25th of February, everyone was concerned because the water level was rising and the dam was almost overtopped. So basically the water would have overtopped the dam, and then this would ensure the collapse of the dam. So 2 hours before the catastrophe, the vice president said they needed a new pipe, a new emergency pipe. However, the sheriff, which was the state responsible there, came to the dam and said, "No problem, we're gonna handle that. No biggie, don't alert anyone." So no one was evacuated. Everyone stayed at home, and yeah. And so 10 minutes before the disaster, this is important. The water level dropped around 2 meters. And muddy water was witnessed downstream, just downstream from the dam, on the toe of the dam. So this is very likely the sign of internal erosion. Basically, the water seeped through the dam and took the earth downstream with them. And so the drop of water means that, that there was a significant seepage through the dam. So significant witness, and that's what that's why the dam collapsed. Okay. So internal erosion, which is why what took down the dam, is something that has to be taken into account. It can happen everywhere in the dam, even surrounding them. The dam, they can take just slight joints in the rock or imperfection, and with time they can make it a more serious issue until the dam crash. So you can put weighted filters on some places so that the water won't seep through and reduce the issue of internal erosion. Oh. So this is how you can recognize internal erosion. So seasonal temperature can make it so that the dam will crack. For example, if the temperature falls behind under 0 degrees, then the ice forms and cracks the dam, and then leaves space for water to come, and again and again and again until the dam cracks. Holes, animal holes, can also be responsible for that. Or the trees, they can make holes into the dam and make it so that water falls. You can also have a direct seepage under the dam, and this can endanger the foundation of the dam. If you see any sign of cracking from the outside, or any water falling from places that it's not supposed to, that means that you have a seeping issue. So the best response to that is to lower the level of the water behind, so that the pressure falls and less seepage is and less water seeps, and then you can resolve your issue. Scan the whole dam and repair it, and then you can raise the level of water. However, that means that you have to be responsible of the dam and do the opposite of what has been done for the Buffalo Creek Dam, which is to take seriously the issues with the dam. So what happened then after this this incident is that the United States changes their legislation, and now every dam was overseen in a significant way by the state, the federal state. Basically, the company had to make sure to prove that they were taking care of the dams to the federal government, because this kind of private responsibility showed its limit, and in the political landscape of the United States, it's very significant, as there's a big part of the right wing which pushes for no federal state involvement and only private responsibility of public goods. And this is an example for why you have to be very careful with this kind of attitude. So this is the reference.
Okay. Thank you. Any questions? Come on. Yes, it's a very good example. I think in this course, I also try to use most of the case from the dam safety, to tell you what is what we call the potential failure mode. Okay, so you can see in each, infrastructure, you may have some potential failure problem. So based on that concept, you can have monitoring the critical issue. Okay, so it is very good. Thank you. Thank you. So next, which one? Let me see. 你报过了？还没，所以你在。我在第一个，这个，OK。OK。
大家好，我是土木4 D 陈建凯。然后，很抱歉，我也是用中文来报告。然后，我今天要报告的灾害是火山爆发。然后，大家应该都知道这个很有名的案例嘛，庞贝，这是一座被火山灰覆盖的城市。然后这件事情是发生在那个西元79年，然后在意大利。然后从这张图我们可以看出，当时灾害是非常的快速与突然。因此，这些人们还来不及有任何的反应，然后就被掩埋。然后我再来要介绍一下这座火山——维苏威火山。其实早在发生这件事情之前就有预兆，就是有发生过地震，但是当时候人们并没有发现，也没有做出警戒。然后，但比较值得令我们注意的是，这座火山目前还是一座活火山，并且在1944年的时候，它也曾经喷发过。因此，如何进行警戒就是我们需要注意的事情。然后讲到火山，就要提到台湾，因为台湾也是有火山的，因为台湾地处于那个板块的交界带。然后这座火山是大屯火山，它也是一座活火山。不过，根据推测，这座火山距离上次喷发已经有10万年到20万年了。但是毕竟它还是一座活火山，所以我们还是必须小心谨慎的对待它。然后，在这里，台湾参考了日本方面的预警措施，将火山喷发的严重等级分成5级。第1级当然是最安全，就是没有任何问题。然后再来从第2级开始，就会开始危及到生命。从第2个是火山喷发可能会影响到周围的区域，然后在第3级是火山喷发会影响到周围的住宅区，不过这个几率较低，所以在这个2、3级方面，只需要继续正常生活，不过要进行观测就好了。然后再来第4级和第5级就会比较严重。第4级的话是火山的喷发会有高几率影响到周围的住宅，所以在预警在处理方面，我们必须对所有警戒的区域做出撤离的准备。然后再来当然是最严重的第5级，就是火山即将喷发或者是已经喷发。在这方面，我们就必须对那个所有受到危险的区域进行撤离。不过，之所以会列出这样5级，主要原因还是因为其实火山是非常难预测的，所以它的 喷发是非常突然的，所以只能做出这样的预警来避免发生更严重的损失。我的报告到此结束，谢谢大家。
So can you go back to the previous page?
这个吗？
Okay. So you say this is from Japanese broadcast.
就是我看到我们好像某个不知道哪个院做出来的，对，看到他的 APP， 然后他说他是参考那个日本的，可是这个是他们自己的，对，他们自己列出来的。
Okay.
对，不过因为我英文比较烂，所以这些都是丢Google翻译。我不知道翻的对不对。
So originally this is in Chinese.
对，它是在中文的。
Okay.
只不过我把它翻成。对。
Okay. So I think this is very interesting for the volcano pre-warning, okay, in a different level. So can you email me the reference?
好。
你再寄给我。好。Okay, thank you. Okay, next please. So which one? This one. Okay, go ahead.
Hi everyone, today I would like to speak about the nuclear disaster in Fukushima. To present this topic, first of all, I'm going to remember the main step for this accident. Then we will see the security system to protect the central. And finally, we'll see the consequences in the world. So, March 11, 2011, earthquake of magnitude 9 occurs, and followed by a tsunami. Before the earthquake, the reactor 1, 2, and 3 was functioning, but the reactor 4, 5, and 6 was in maintenance. And before the earthquake, after the earthquake, the reactors, it's okay, but after the tsunami, everything was destroyed, and the central will be isolated electrically. So because of that, there will be the fusion of reactor 1, 2, and 3, and overheating of the activation pool. There will be 20,000 victims and 2,500 missing. There will be a lot of population evacuated and a lot of radioactive pollutants released. And this accident is a little bit different from the other accidents like 3 Mile Island or Chernobyl. It's because in accidents the problems of security insufficient. So let's have a look at the security system. There are a lot of security systems in the central. You have a security system for terrorism, security system for pollutants, but here we'll see only the main security system for this case. So the first security system is 30 seconds before the earthquake, the main tremors. The sensor decided to stop the chain reaction in the reactors 1, 2, and 3 and to start to protect the central. But after the earthquake, the central is electrically isolated because the electrical cables are cut. And to resolve this problem, we have generators. And with the generators, we can start to reduce the temperature in each reactor or core. But 51 minutes after the earthquake, the tsunami occurs. And to protect the central, we have a dam, but the dam was 5.7 meters height. And the waves of the tsunami was 14 meters height, so it wasn't enough. And because of that, the central and the generators is destroyed. Fukushima is one of the most important nuclear disasters. And there will be a lot of debate about the electricity, the nuclear electricity consumption. A country like Germany will decide to reduce dramatically the part of nuclear electricity. France will decide to reduce a little bit. Japan, they decide to reduce dramatically, and then now they want to have, I think, about 20%. There will be new studies to be sure that every central can resist if you have a disaster like that. And a lot of central in the world didn't have emergency generators, so there will be an installation. And the point is for France, but there will be a fraction of units able to intervene rapidly if we have a central problem. Thank you for listening.
Okay, thank you. Any questions? Okay, I think one of you already have yes. Okay, coming. Okay. So next, okay. So which? This one. Okay. So. Okay.
Hi, so I would like to present the Rana Plaza collapse, which is a disaster that occurred in the capital city of Dhaka on April 23rd, 2013. It's one of the deadliest and biggest industrial disasters that ever happened. So first of all, what is the Rana Plaza and what happened? The Rana Plaza is an 8-story commercial and industrial building where banks, several shops, and several shops were located on the lower floor, and the clothing factory, nursery facilities for its workers were located on the 6 upper floors. In the factory, they manufacture clothing for several well-known brands like Prada, Gucci, Benetton, and so on. And what happened is that several cracks were discovered on April 23rd, and they were recorded by a national TV channel. And right after that, the building owner said that the building was safe, and that worker, even if they evacuated the building, workers had to return the day after. And the workers were also threatened by the companies not to be paid for several months, so they had no choice but to return to work. And the day after, the building collapsed at 9 a.m. Around 3,100 employees were present, over 5,000, and 2,500 were injured, and more than 1,000 were found dead after a search that lasted like 2 weeks. So what are the causes? There are 3 main causes, which are construction causes. The first one is that the building was built on a fielding pond. It's like a small lake, but fielding. So the structure was weak. And then it's really common in developing countries like Bangladesh to use substandard construction materials, though they are not strong enough to support the structure. And then the main cause of the disaster is that the building was converted to industrial use. At the beginning, it was designed to be a commercial building, but then 3 floors were added without a permit, and the industrial use began. And this is the main problem because of the industrial use and the overuse of sewage machine. There were a lot of electricity outages, and they had to use emergency generators, which were located on the upper floor, and this created vibration, and as the building was not designed to be an industrial one, it could not support the vibration. So what is the strategy for this type of disaster prevention? The first one is that immediately after the disaster, like 1 week after, several well-known brands got together to create the Accord on Fire and Building Safety in Bangladesh. This is an accord where several actions are took. The first one is that they inspect factories, which means that regular fire building inspection are done, and monitoring remediation is also done after this inspection. So, for example, they will check the humidity, the temperature, the building structure, and if it's not good, they will do a remediation plan, and they will help to get this monitoring plan. Then there are also safety training for all the workers and for them to know what to do if disaster happens. And this ARPL also help workers to resolve safety complaints, so they can say they don't want to work in bad safety conditions. There were also other action. For example, Bangladeshi unions demand for law reform in Bangladesh because it's not, the point is not to act after a disaster but prevent it. So even if some action are taken, it's still common in Bangladesh and in developing countries to have this type of disaster. That's all.
Thank you. Any questions? I think I'm not sure if you already go to the convenience store in Taiwan. I'm not sure. It's they will show how many people inside and what is the maximum for the entrance. Okay, so I think this is most popular in the monitoring in every store or buildings. Okay, but however, I think this is the structure of safety monitoring issues. So maybe later I will show some of the application. Okay. Okay. Next. Which one?
902.
903?
Yeah.
Yeah. Okay.
Okay, so today I will present you the Tacoma Narrow Bridge case. So before the disaster, I will present you some characteristics of the bridge. So it's a very long bridge with 1,800 meters of long. The longest span it was nearly 1,000 meters, so very long span, and nearly 60 meters of clearance below. So this bridge opened the 1st July, and it collapsed several months later. So it's not a long bridge. You don't have a long history. At this time, it was the third largest suspension bridge in the world, so it was a really important bridge at this time. And its value of construction was $1 billion USD. I mean, today USD dollar. So $1 billion for just 5 months or 6 months. It's not very a good thing, I guess. So what happened? I want to show you this video, but I don't know how to do it.
Play the video.
Yeah.
Yes.
Sorry.
Let me do it.
So I want to show you this video because I think it's very important to understand what
来，
happened.
大家一起吃，买麦当劳分享盒加点饮料买1送1。
I have always felt if you know what you're going to do in advance,
I need skip.
then
So yeah, as you can see, the span that twisted a lot, and twisted not like very important thing. And it's twisted on the bridge collapse. So by chance, no one was injured or killed. Everything, just 2 or 3 cars were destroyed, but it's fine. Just the high value of the bridge that is a problem, I think. So what happened exactly? No, it's very difficult. Sorry.
No, that's okay.
Okay. Okay, so the explanation of this event is that an ordinary bridge design has a gap between the structure to let the wind pass through through the bridge, and the Kagomano's design was not like this. So the wind can't pass through the structure of the bridge, and it creates a depression that made whirlwind inside the bridge, and so this event creates. I mean, scientists at the epoch when the bridge were constructed said, "Ah, yeah, the bridge twisted a little bit, but it's not a big deal." But this day it was a very windy day, so the bridge collapsed. Didn't it can't. I want to show you something else, but no, maybe it doesn't matter. So we can use this formula to calculate the through-sound frequency to know how the bridge will respond to this kind of wind. So with the velocity of the wind, a through-all number, and the characteristic length. So how it can be avoided by letting the wheel happen to get through the structure, of course, by creating gap in the structure, and by using dynamic and model analysis for the design of the bridge. After this event, engineers understand that it was very important to make calculus before and to make model before to not create something and hope that it will not collapse in the future. So it helped a lot of people in the future. So thank you.
Okay, thank you. Good. I think in Taiwan we also face the wind flow problem of the bridge, especially in the mountain area. Okay, so some of the professors in the civil department, civil engineering, they research the wind behavior, and also we have a wind tunnel in our campus. Do you know that? No, we have a wind tunnel. Yeah, so we can build some physical modeling and put inside of the wind tunnel to simulate how big. I'm not sure because not so big. Maybe the width is 2 meters, high 2 meters, but because there's they need some distance. Because I'm not a major of the wind technology, but there are some turbine to generate a wind with a different speed. So I'm not sure how much the depth, but I think in the next time I visit the wind tunnel, maybe the depth more than the 2 times of this classroom. So have you been there? No, not yet. Maybe I can ask the Professor Zhu. He's the director of the wind tunnel. Okay. So in NCU we can simulate the wind behavior with a small physical modeling. Okay, that's good. Okay, next. So which one? This one. Okay. Okay. And space.
Okay, so another bridge today. I represented the Tasman Bridge disaster. So where is the Tasman Bridge and why did I choose this one? The Tasman Bridge is located in Tasmania, so it's the southeast island of Australia. Why this case? Because I used to live in Hobart last year for 6 months because I was doing an internship there. So the bridge is exactly located here. So here is the city of Hobart, and it's separated in two parts, like the western part and the eastern part. So what's important is that at the case of, well, during the time of the bridge, of the collapse, there were no bridge here. So there were just this bridge as a link between the two parts of the cities. And well, we will talk about it later, but they were like, this part was more like the residential area. So like it had a big consequences on this. So what happened the 5th of January of 1975? So a cargo ship, this cargo ship just collapsed. So it was heading up the Devon River. So here is the Devon River. So it was coming from here, heading up to the. So here there are like some factories of heavy metals. So it was heading up, and the wind was strong, and the current was strong as well. So he was supposed to pass through the middle path of the bridge, but it just like the captain just lost control and lost speed, and it was just impossible to pass through this one. So he tried to pass through another one, but it's not big enough and large enough to pass. So he just crashed into one of the pylons. So he crashed into the pylons 19th, and it brought the other pylons collapse because of the inertia. And so, what about the consequences? So first, we can see that with those images that the cars and like some cars just drove over the gap, and like I think it's like 5 people died in from the cars, and the boat sunk, and 7 people died during the sink. So what about the consequences? So as I said, it just separated the two parts of the cities. We have to know that in the western part, like there were all the, let's say, the activities, the works, the offices, the cinema, sports. So it just like isolated this part of the city, and still there is some consequences, but they started to build another neighborhood here. And so here it's a bit isolated compared to the other side. First of all, the most problematic is that they implemented a ferry line the day after the disaster to be able to cross between the two parts, but it was really crowded and not really efficient. So they decided to build a temporary bridge. What's the name? Sorry. It's like a typical temporary bridge to mainly used in this case. And so this one just a temporary bridge, but they built another one in and what about the bridge itself? So they tried to build again the 2 panels that collapsed, but because there were too much debris in this area, they just built again the pylon 18th, and they just leave it as it is for the 90s. What about the solutions they could have? Is like some bridge exists, and they can stay as it is if just one of the pylons collapsed. I mean, like if in this case it could have saved the bridge as if just the pylon 19th collapsed, the bridge could have stayed as it is. And another thing is that when they started to, well, they built another line on the road, so they changed a bit the bridge. So
now here we come to say like why did I choose this case for this class. But first I would like it's just like a human error, so the captain just didn't get so much attention. So how can we monitor this kind of stuff? Actually they did. They put sensors around the bridge here and in the part before to measure the currents and the tide height and the wind speed in order to prevent the cross of the bridge. I mean, like if the weather is bad, like they will just forbid the bridge to head up to the river. And they will also, in case of like really big ships, they will they will stop the traffic on the bridge to make sure that there are no car on the bridge. So yeah, like I think it's interesting in terms of saying that the monitoring is possible even for human error. Thank you.
Thank you. Yeah, I think this damage is on a human error from someone doing Apple maybe. So for this kind of the situation, I think we should prevent. I think I would like to say we should decrease the risk. Maybe in the beginning of the design procedure. So maybe we can have some longer span. This means that with the less pier of the bridge. So this is one option. And the other option is what we say the monitoring. Okay. The before that is active action, and for the monitoring is passive. Okay, so I think it's a two-way for to prevent this kind of the damage. Yeah. Okay, good. Next. Okay. You. Okay, you first. So which one?
604.
604
Yeah.
on this one. Okay, go ahead.
Okay, everyone. I would like to explain about the landslide triggered by rainfall. Actually, this case in my country, and then as you know, in my country, so many disasters occurred. So many researchers say that in our country like a laboratorium of disaster. This is the outline of mine, and then okay, next to the background case landslide triggered by rainfall, and then the date 2016 in Central Java, Indonesia, and then the victims 47 dead, 15 gone, and then 11 injured. And why I said triggered by rainfall, we can see the this figure. This figure, the precipitation rate at the time. If you see the cumulative rainfall, the landslide happen when the cumulative rainfall very high, and then actually we can see the pattern of rainfall also here. And then where is the place? Here is the place. So this is our country, this is Taiwan, and this is our country. And then the landslide happened over here. Actually, why it can happen? Because in our country, so many volcano mountain, and then it will make some mountain full with residual soil or colloquium soil. If you see here this map, we have so many mountain over here. So maybe if you want to travel to our country, you will get so many good views over there. But somehow, sometimes the mountain will erupt. So be careful over there also. Here's the place as you see, the main position of the lens is actually over here, but the debris flow comes over here. You see this this one. You can imagine how big, how large the landslide is. This picture I took from Google Earth. 2015, 2017. There's different over there. And this is from UAV. I think also from at the location. And then you see there is small house over here. And then this picture I took by myself. I go up to the main position of the landslide, and then I take the picture to the outside, and this is the house. Okay, so next to the prevention. Actually, our country has some prevention also. For the example, for forecast, maybe Taiwan more better for the forecast, because in our country is so big, so maybe it cannot monitorize in one time, and then maybe it takes slowly for monitoring. And then actually in our not our department actually, in climatology department in Indonesia, they always make some prevention also for rainfall rate each month. So they will inform us how's the rainfall rate. So we will care with the situation. And this is the evacuation route I found in the location. You see this place. This place is in at the down slope of the hill. So it's so how to say, it's so scary over there. Okay, thank you very much for your attention. That's all.
Okay, so this is because of the typhoon or
No.
the rainfall?
Only rain.
Only the rainfall.
Yeah.
Okay.
Because it's very different with Taiwan. We have so many.
So I'm not sure how many typhoon each year in Indonesia.
There's no typhoon over there. But
really?
yeah, there's a typhoon. But sometimes we get the typhoon effect from the, we get typhoon effect from the south area and then the north area. If you see this,
Yes.
okay, and then this one, sometimes when those places get typhoon, we get the impact also. But actually in Indonesia, we only have 2 seasons. Rain season and then like summer season, but not summer actually, because sometimes rain also over there. Yeah. Not summer actually.
See. Okay, good. Thank you. Yes, because you know that the Philippines right now have a lot of typhoon each year. Okay, so this is the zone of the typhoon. Of course, the south.
Yeah.
Okay, I'm not sure of the central line where it is.
Central. Yeah. The central line.
Is it here?
Here.
Here.
The whole.
Okay. Yeah. Okay, good. And next. Okay. 要
状况比较晚上约在这里，我电脑是因为我寄给老师应该
我应该是这个，不是这个啊。所以还是你是有传到 email， 我可能没有 copy 过来。
但是我比较晚传，这样
可是你有随身碟？没有随身碟。有没有同学有随身碟？可以借他一下。Anyone have the flash disk? Okay, I think. Okay. Yeah. Okay. So before that, I would like to say, if you try to have play the video or online YouTube, actually in a PowerPoint you can directly have the link for this kind of the function you can find here. Let me show you. Okay, let me try something. So if you try to have some of the here, and where it is? Sorry. Because this is another. Oh, okay, maybe later I'll check for you. Okay. Which one? This one? Okay. Okay. 好。我今天要报告的是莫拉克台风在里面的小林村的灾害。那我这边先简单介绍一下，小林村是在高雄甲仙区的一个以大武龙族的原住民，然后他们主要是以农业为生的。那我们在2009年8月6号到8月10号的时候，莫拉克侵袭台湾，那它对台湾造成非常重大的灾害，然后也是前所未有的雨量。那它主要的降雨也是集中在台湾中南部的山区，所以对中南部的灾害影响非常的深。那我们可以看到莫拉克台风的路径大概是这样穿越台湾，那它对台湾造成了673人的死亡跟26人失踪。那我们这边可以看到时雨量，主要都是以台湾中南部的山区为主，那它最大的时雨量会超过每小时大概90毫米，那对台湾是影响非常深的。那是在当天上午6点16分的时候，然后这边小林村上面的山头，它发生了山崩。那它用非常大雨量携带非常多的土方，然后往小林村的方向冲刷。那它第一次崩落的时候，在小林村的北方，也是山头下面地方形成一个自然的堰塞湖。那它堰塞湖形成大概过50分钟之后，它支撑不住了，所以它把累积的雨量一次携带到整个小林村，所以小林村几乎是整个被淹没。那会发生这么严重的问题，主要是因为它旁边的仙度山是所谓的顺向坡，它面对小林山的方向是顺向坡，它的土脚被冲刷狭带，它的那个地层支撑不住，所以整片形成滑来，造成这么严重的灾害。那我这边建议跟主要是需要更重视一下那个土石流的浅势溪流。那在台湾，像小林村这样就是高风险的土石流规划区的聚落跟桥梁还有道路的话，大概还有30几处。那我们台湾对于土石流的预测主要有几个方向，像刚刚小林村那种比较大型的复合式地形的预测，主要是用所谓那个
用一种那个雷达检测的方式，然后用不同地形套叠检测它滑坡的状况，然后进而去预测它所造成的风险。那台湾目前也有在做土石流的即时预测，主要也是用钢索的检测，然后架设摄影机，然后以及地声的那个回应，然后对整体的循环进行检测。那主要政府还是需要有足够的强制力，对于这种高风险的区域跟较多人的环境进行强制性的处理。那我的报告就到这边。
Okay, thank you. Okay, so you know that the Shaolin Village, the landslide of the Shaolin Village is the most critical issues recently. More than 400, I don't know, 500 people buried in that time. Okay, because of the very big landslide. But just he said maybe we need some education plan, right? But I would like to say in that area, the shelter also buried. So means that because it's the landslide, is so big, so all the village were covered by the sand and the stone and the mud. So how about the plan for evacuation? I don't know, for this kind of the scale, it's not so easy. Or otherwise, we need to evacuate all the people of this village to another village. Okay, but I think this is very difficult to do in the during the typhoon event. Okay. Okay, sure. So everyone finished. So maybe some of you will keep continuing at the next week. Okay. So before I continue the class, maybe we can have maybe short break, 5 minutes break. Okay. Okay.